Bismillahirrahmanirrahim. Assalamu alaikum, dear students. I am Zahida Khalid. I hope you are good. In the last lecture, we discussed about the properties of gases. We discussed it in very detail. So these properties are what? Diffusion, effusion, pressure, compressibility, mobility, and density. And I hope you have learned these properties. And in the last lecture, I gave you some homework. Some of the students sent me, but most of them did not. That's very bad, beta. So our next topic is the effect of pressure and temperature change on the volume of a gas. Before this topic, I want to discuss about a theory which is called kinetic molecular theory. This theory is related with the movement of molecules of gases. So that's why it is called kinetic molecular theory of gases. So there are some postulates or there are some important points of this theory which are as follows. First point, gas molecules are in constant motion. They move in a straight line until they collide with another molecule or with the wall of container. So it means gas molecules are always in the constant state of motion and they always move in a straight line until they collide with another or with the wall of container. Okay. Now the second point is the pressure exerted by the gas in a container is due to the force exerted on the wall of container. Look at this diagram. This is a container and it consists of different molecules. Let's consider this molecule. So the pressure exerted on the walls of the container. So we can say the pressure of gas is due to the force exerted on the wall of the container. Now third point, the average kinetic energy of gas molecule is directly proportional to the Kelvin temperature. So the average kinetic energy of the molecules when a gas molecule collides with the walls of container will not change when the pressure decreases at constant temperature. So what does it mean? It means the average kinetic energy of gas molecules is directly proportional to the temperature. If you increase the temperature, average kinetic energy of the molecules is increased, and if you decrease the temperature, the average kinetic energy of the molecule is decreased. So the average kinetic energy of the Coulomb molecule is not changed at constant temperature, right? Now next, fourth point, there are large empty spaces between the molecules. You know gas molecules are very far away, so that's why there is large empty spaces present between the molecules. Now the fifth point is, on increasing pressure on the gas, the distance between the molecule decreases. So the volume of gas decreases. It means the pressure is inversely proportional to the volume. If you increase the pressure, the volume is decreased. If you decrease the pressure, the volume is increased. So these are the 5 points of kinetic molecular theory of gases. Right? Now come to the topic that is in your book, that is effect of pressure and temperature change on the volume of a gas. First we take the effect of pressure on the volume of a gas. Right? So according to the kinetic molecular theory, gas molecules are in constant random motion. This is your first postulate of kinetic molecular theory. So the molecules always collide with each other or with the walls of container in which they contain, right? So what will happen, as a result of which pressure is exerted by the gas molecule in a container at constant temperature. When pressure over the gas is increased, the distance between the gas molecule decrease, as a result of which volume of a gas decreases and the collision of molecule increases, which exert more pressure. So this is about the last point of kinetic molecular theory. The last point of kinetic molecular theory says that pressure is inversely proportional to the volume. If you increase the pressure, volume is decreased. If you decrease the pressure, volume is increased. Look at this diagram. This is the jar of gas. These are the molecules of gas. They move here and there. Let's suppose this molecule move in this side, this molecule in this side, this in this side, and this will in this side. Okay? And the volume is large. In this container, large volume, few collision per unit area. That means the collision is less because volume is large. So collision between the molecule is less and the pressure is low. So conditions, what are the conditions? Volume is large, collision is less, and pressure is low. Right? So on the other hand, next, if you apply more pressure, what will happen? Molecules become closer and the collision is frequent and the volume is smaller. So now what are the conditions? Smaller is volume, more collision per unit area, and higher the pressure. So look at this. Here is the pressure less and here is the pressure large or higher. So with the higher pressure, volume becomes smaller and collision between the molecules become greater. But with low pressure, volume is large and collision is smaller. Collision between the molecule is not frequent. So this is the effect of pressure change on the volume of a gas. Clear? Now the next is the effect of temperature on the volume of a gas. Now what is the effect of temperature change? So we know that according to the kinetic molecular theory of gases, kinetic energy is directly proportional to the Kelvin temperature at constant pressure. When we kept pressure constant, what will happen? If we increase the temperature, the kinetic energy of the molecules will increase. And if you decrease the temperature, the kinetic molecular energy is decrease. So it means the kinetic molecular energy is directly proportional to the Kelvin temperature. So what will happen at high temperature? The gas molecule hit the walls of container more rapidly and energetically. That means if you increase the temperature, the molecules will move more frequently and they hit the wall more frequently, more rapidly. This increases the internal pressure due to the frequent collision of the gas molecules. When their collision is increased or they collide with each other more frequently, as a result, they will increase the internal pressure of the gas molecules. Okay? When they increase the internal pressure, the volume of gas increases due to restore constant pressure. So as a result, the volume of gas increases to restore constant pressure. Okay? So now students, there is some tricky question. One tricky question, I give you the answer of this tricky question. Question is, air molecules are free to move inside their container. Justify it. Okay? When a balloon is filled with air, it expands. There is no attractive and repulsive forces between the molecules. You know that gas molecules are very far away and they have large empty spaces between them. So that's why there is no attractive, no repulsive forces between the molecules. As a result, gas expands until it takes the shape of its container. Therefore, air expands to fill the interior of the balloon evenly and the molecules are free to move inside the balloon. So this is the answer of this question. You can learn it. Now next two questions you have to do in your homework. Question number one is what is the role of ozone in atmosphere? The answer is on the page which is present in your notebook. And question 3, you can take help from that page. Question 3, what is the effect of temperature on the density of gases? So we have done density of gases. You can take help from that topic, density. Read that topic and find the answer of this question, right? And beta, you seriously learn this topic and then send me the homework, right? Best of luck. Thank you very much.